Okay, this is number 18 from the homework section in section 1.4. They ask us to find the domain and range of this function, okay, and they give us the graph, which is helpful. Okay, so the domain is the set of all x values that are defined in the function. In other words, the numbers we can put in for x to get something out. Now, when you see a square root, you know automatically there might be a problem because certain numbers, negative numbers, don't have square roots, at least real square roots. Okay. But based on the graph, we can actually answer this question. The domain is the values of x, or it's the set of values of x that are somewhere on the graph of this function. So if we look at the graph, we see from left to right, that's the x-axis, so these are where we see x values. The graph doesn't even start until right here. Okay? And that point right there is the x-coordinate of, well, what is it? It's between 1 and 2, so we call it 3 halves. Okay, so starting when x is 3 halves, it looks like every x value you can imagine is somewhere on our graph. You know, when x is 2, there is a point on the graph with an x-coordinate of 2. When x is 3.1, there is a point on the graph that has an x-coordinate of 3.1. So we don't see any part of our graph from left to right until we get to 3 halves. And then every x-coordinate you can imagine past 3 halves is on the graph somewhere. Okay, so what does that mean for the domain? It means the domain is 3 halves, comma, infinity. Okay, because right here, x is 3 halves. We have that point on the graph, and every x-coordinate bigger. Okay. Now, range is the exact same thing, but with y values. So when you're wanting to find the range of the function, you look on the vertical axis, the y-axis, from bottom to top. And you kind of think, what y-coordinates do I have on the graph? Okay, so imagine going up the y-axis, looking left and right, until you get to a point that's on the graph. Now, many functions go all the way left and all the way right, all the way up, all the way down. But this one's special. Makes it a little bit more of a hard problem to answer. The smallest y value we see is right here, and that's the y-coordinate of 0. Okay? So the range starts when y is 0. And what y-coordinates do we have? Well, as I move above the x-axis and I get into positive y values, it seems that my curve continues to move up as it goes to the right. Okay. So I don't anticipate there being any y values we don't have on the graph once we're at least at the y-coordinate of 0. So above 0, every y value seems to be covered. Okay, so the range is from 0, including 0, okay, all the way to infinity. Okay.